Hey class, next little video talking about conservation momentum. So we're just going to look kind of the last few questions of our, again, conservation momentum practice sheet here. So I'm going to be doing questions 7, 8, 9 from the back side of this worksheet. Again, just hammering home, how do we understand conservation momentum? Again, it's all that same formula, so just really working through what I'm thinking about when I go through this and trying to how to tackle these questions, how to look at them. So let's go through 3 more here. All right, question 7 looks like this. Okay, a 50-kilogram woman riding on a 10-kilogram cart. I don't know if it's a shopping cart or whatever it is, but she's on some kind of cart, moving at 5 meters per second east. Okay, so in the beginning here, the two of them are together. They're one. So again, we don't actually have 2 objects here. We have 1 object here. So our momentum initial will kind of be like the velocity multiplied by mass total. Okay, so that's going to be the momentum beforehand. In one of the questions in the last one, like in the other video, we had where 2 things stuck together and slide it off. This one, they're already together, and then they're going to kind of break apart. Kind of like an explosion, but a little less violent. Okay, so here in the beforehand, I just want to find the beforehand before we get too far away. My velocity is 5, and my mass total is going to be 50, and the 10 is 60. So I have 300 kilogram meters per second. Okay, so that's momentum before. My momentum after has to be exactly the same. Okay, so my momentum final of the 2 objects has to be the same as 300. The woman jumps off the cart and hits the ground at 7 meters per second. So obviously they're both east, by the way. I forgot to add this in. Both east, so both moving right, so everything's positive. All right. If everything was going north and then west, we'd have to bring in vectors. No vectors yet. That'll be from the next video, 2D. But we're both going east. But she sped up here. Basically, she jumped off this cart and got faster.
Kendon, would you please go to the auto shop?
Scared me a little.
Kendon, you're needed in the auto shop.
So she ended up going faster, which is okay. So if I look at the momentum here of just the woman, so I put momentum kind of A. I didn't have momentum A back here because they were together. I'm going to go 50 times 7, which means momentum of 300, like 350. I have a momentum of 350. Okay, that means basically, like, what is this cart? This cart has momentum, and if you watch my intro, you'll kind of understand this. How did I go from 300 to 350? Well, again, the other thing could have a negative momentum. Okay, I'm going to do this again in the understanding way, and then I'll show you kind of how you do it here. I have to know. I know that if there's 300 beforehand and she already has 350, the momentum of the cart B has to be negative 50, which means the velocity is just going to be going the other direction, basically west. Okay, and so to find velocity, I'm going to go momentum divided by mass, which is 50 divided by 10, which is negative 5 meters per second, which means west. Okay, and so there's how to do that question. If you wanted to do it a little more like this stays the same, a little more just mathematically, you kind of go like this. 300 equals 50 times 7 plus 10 times unknown V2 final. And so you kind of get this. This will end up being 350 plus 10 times V2 final. Okay, minus 350. Minus 350, you end up getting like 300. You end up getting 50 equals 10 times V2. This is negative 50, sorry. V2 final. And hey, divide by 10, divide by 10. You end up getting the exact same thing formula-wise as you do understanding-wise. Okay, you should get negative 5 meters per second west. Okay, I like doing the understanding way. Formula way works totally perfect. Both work great. Just wanted to kind of talk it through. Okay, let's go to question 8. Question 8. I think this is another sticking together one, but they start off. Okay, yeah. So this one is similar, but just the opposite way. A car with a mass of 212.46 moving at 29 meters per second. So I can say that momentum object A, that's not an A, initial equals. Okay, that times that. Let's do that. 1245 times 29 is 36,105. Okay. and strikes a 2,175 kilogram car at rest. So momentum B, 0, at least initially. If the two cars stick together, what will the speed be at the end? Like, what speed will they actually move off with? Well, again, that means this momentum plus this momentum, which is 0, has to equal the momentum after. So this is going to be momentum, like final, is going to be 36,105. Now again, these two things are stuck together. So to get velocity, velocity is going to equal momentum final over mass total. Okay, these masses they've combined to have a mass total, and so that's how I'm going to do this. 36,105 divided by, what's my mass total? That plus that. Let's do that quickly. Actually, I should have it on my answer key already. What should I do? 3,420. That sounds right. That sounds right. And when I do that, I get an answer, a velocity, of 10.56. And that's how fast these two objects are now going afterwards. Makes sense that it obviously slowed down quite a bit because it hit another vehicle at rest, and so they're still going to slide off at this initial velocity here. Cool. Last question upcoming for conservation. Question 9, another football question. We have 3 things here though. Okay, so basically we just want to make sure we put our positives and negatives of momentums on the right side here. Okay, a 92 kilo fullback, if someone holds the ball and runs, running at 5 meters per second. So they are, we're going to put momentum A, okay, 92 times 5, which gives me momentum of 460. Okay, I don't really give a direction, so just make a direction. We're going to say it is 460 east. Okay? He attempts to dive across the goal line. All right. Just as he reaches the goal line, he is met by 2 people in midair. Okay, so they're in midair, which means the nice thing is when we say in midair, they can't put any more force, so it's all up to momentum. Okay, by 2, there's 2 now. There's 2 other people. There's momentum B and momentum C, both going this way. Okay, one moving at 2 meters per second, so we can go 75 times 2, which is 150. And the other moving at 4 meters per second, 75 times 4, which is 300. Okay, if they all become entangled as one mass, with what velocity do they travel and does the fullback score? So here we're looking at conservation of momentum. Okay, we have, this is the overall initial. There's nothing, this is just step A. Okay, there's a full afterwards. Okay, but what is the net momentum of the beforehand? I have 460, okay, positive, and then I have a negative 150 and a negative 300 because they're going the opposite direction. Okay, and so if I have 460 positive, and then I add these two up and then a negative 450, technically this one's still winning. This person with the ball is still winning, barely. Okay, my net momentum equals positive 10. So that has to be the same afterwards. Okay, so it says, with what velocity do they travel at? Again, they became all entangled, so this is very similar to the last question. Okay, momentum final is still going to be 10. I still have to have that same momentum beforehand and after. I just want to know the velocity now. And again, same thing, to get the velocity, it's momentum final over mass total. Okay, so I'm going to add the 92, the 75, the 75. When I do that, I get a mass of 242. So 10 over 242. And again, that gives you a velocity, 0.04 meters per second. Okay? And if you don't understand the question of did he score, again, he's just at the goal line. As long as he moves like 1 millimeter forward, technically he'll score. And so again, he is still moving forward. This person with the ball is moving forward. Not very fast, I get that. But because it's over 0, because he still is moving forward, yes, he scores. Okay? So hopefully this makes the concentration of momentum a little more straightforward, or you understand a little better. Next video we'll get into those 2D, all those vectors. I'd say fun stuff. May not be that fun. Again, it's just understanding the directions and how things move. Okay, awesome. Thanks, class. I'll talk to you soon.